Besides the explicit formula of arithmetic sequence, the general formula can also be used to find the rule for a specific number pattern. Learn the procedure here in Mathematics of Engineering. In cases when the explicit formula is hard to remember, one can still devise the rule of a pattern using the general formula. Take the case of the sequence 4, 8, 12, 16, and so on. The initial value 4 designates n as 1. The second n has a value of 8. 12 is the third n, and 16 is the fourth. The difference between terms is also constant at positive 4. The general formula is outlined as a sub n is equal to d multiplied by n and add or subtract c, although adding or subtracting c only comes on the second step. So for the pattern, the initial general formula is a sub n is equal to 4n. Having this formula, we can check the terms starting at n equals to 1. A1 turns out as 4 times 1, which is equal to 4. At n equal to 2, A2 is 4 times 2, which is 8. At n equal to 3, A3 is 4 times 3, yielding 12. Then, at n equal to 4, A4 is 4 times 4, which is 16. The results are as itemized in the sequence, so the rule is a sub n is equal to 4n. The next pattern is 5, 8, 11, 14, and it continues. The common difference is 3, which can be plugged in the general formula to come up with a sub n is equal to 3n. Now check the terms with the initial rule. So at n equal to 1, a1 is 3 times 1, which is equal to 3. Note that this is not the same with the initial term 5. Thus, a modification is required, so the secondary general rule is a sub n is equal to 3n plus 2 to account for the difference between 5 and 3. With the fixed formula, we can check the terms once more, so at n equal to 1, a1 is 3 times 1 plus 2, which is 5. Next, at n equal to 2, a2 is solved as 3 times 2 plus 2, which is 8. At n equal to 3, a3 is 3 times 3 plus 2, which is equal to 11. Lastly, at n equal to 4, a4 is 3 times 4 plus 2, which is 14. Such terms resulting from the formula are the exact ones from the pattern, so a sub n is indeed equal to 3n plus 2. Observe the next number pattern, which is quite similar with the previous example, but with a different starting term. Just the same, the common difference is 3, so with the general formula template, a sub n is equal to 3n. Again, check for similarity of terms, so at n equal to 1, a1 is equal to 3 times 1, which is 3 and not 2. So a modification is again required by adding another term. Thus, the formula turns out as a sub n is equal to 3n minus 1. Check the terms once more. So at n equal to 1, a1 is 3 times 1 minus 1, and that is 2. At n equal to 2, a2 is 3 times 2 minus 1, which is 5. Then at n equal to 3, a3 is solved as 3 times 3 less 1, which gives 8. Finally, at n equal to 4, a4 is 3 times 4 minus 1, and that is 11. All of the values are those from the pattern, so the general formula is a sub n is equal to 3n minus 1. Another example is -3, -1, 1, 3, 5, and so on. Solve for the common difference, which is 2, and plug this into the general formula, so a sub n is equal to 2n. Check for similarity of the initial terms, so at n equal to 1, a1 is 2 times 1, which is 2, and this deviates from the initial term, -3. So the formula will be edited by subtracting 5, making the formula a sub n is equal to 2n minus 5. Now check for the terms starting at n equal to 1. So a1 is 2 times 1 minus 5, and that is -3. At n equal to 2, a2 is solved as 2 times 2 minus 5, which is -1. At n equal to 3, a3 is 2 times 3 minus 5 to give 1. Then at n equal to 4, a4 is 2 times 4 minus 5, and that is 3. For the last term n equal to 5, a5 is 2 times 5 minus 5, which is 5. All values coincide with the terms in the pattern, so the final formula is a sub n is equal to 2 times n minus 5. Evaluating the general term is much simpler, as one only needs to substitute the values of n. For the first example, given the rule a sub n is equal to 7n minus 11, the first 3 terms and the 34th term are required. So start with n equal to 1. So a1 is 7 times 1 minus 11, or that is -4. At n equal to 2, a2 is 7 times 2 minus 11, which is +3. And with n equal to 3, a3 is 7 times 3 minus 11, simplified as 10. The 34th term is computed using n equal to 34. So at n equal to 34, a34 is 7 times 34 minus 11, which is 227. Another example is one with a sub n equal to -7.1 minus 2.1n. The task requires the first 3 and the 27th terms. So with n equal to 1, a1 is computed as -7.1 minus 2.1 times 1, and that is -9.2. With n equal to 2, a2 is -7.1 minus 2.1 times 2, which gives -11.3. Then at n equal to 3, a3 is -7.1 minus 2.1 times 3, yielding -13.4. Lastly, at n equal to 27, a27 is -7.1 minus 2.1 times 27, giving -63.8.